Okay, so today we're going to look at inequalities and interval notation again, but this time with compound inequalities. So it's going to be a little bit different than the and and ors that we looked at yesterday. Okay, so compound inequalities look like this, and there are two types. We're going to look at the simple first, and then the more complicated second. Okay, for the simple first, it looks a lot different than the ones we were looking at yesterday. Okay, rather than two separate statements of inequalities, we have one with a common x in the middle. Okay, so to solve this, it's pretty straightforward. You're going to solve it like an equation you would, but this time you're going to do it in 3 spots versus just 2 for a normal equation. Because we have 2 different inequalities, so whatever you do to one side, you have to do to all 3 sides. So the first step would be, you want to get the x by itself, so you're going to subtract 4 from all 3 sides of your inequality. Okay, so I end up with negative 6 and positive 2 on either side. And then next, to get the x by itself, we have to divide by negative 3. All right, now, when you're dividing by negative 3, again, an important note to make here is that when you divide or multiply by a negative number, your inequality signs will switch. So these are both less than. After you're dividing by negative 3, they will both switch to be greater thans. So we're going to have 2 on one side, x in the middle, and negative 2/3 on the right-hand side. So this would be your answer for the compound inequality that we're dealing with. Okay. All right. So this is our answer again from the other slide. Now, another important thing to note for all these compound inequalities, and this is very important, all compound inequalities are ands. Okay, so they deal with all the rules that an and inequality from yesterday would deal with. Right, there are no ors for compounds. Okay, so another thing to look at for this is, if you remember from yesterday's notes and video, if you put the x on the left side of your inequality, that means you can follow the arrows. So when you're graphing negative 2/3, you can make the arrow go to the right. But for the 2, since the x is on the right, you can flip it around if you wanted to do something like this, where the x is on the left and now the 2 is on the right. The problem didn't change because everything just flipped around, but it still says the same thing. But now you can see that the 2 is going to the left. Okay, you don't have to do that, but I'm just showing you an opportunity for you guys to, maybe make it easier. This might make it harder. It's up to you to use. Okay, so now we graph this. So at negative 2/3, we have a parentheses. At positive 2, we also have a parentheses. Since they're both facing each other, we're just going to graph in between the 2 parentheses. Okay, then we finish this off with the interval notation for this graph, which would be from negative 2/3 with parentheses to positive 2 with parentheses as well. All right. We're going to see another example of a simple compound inequality right here. Okay, again, we have a simple compound inequality. You have an x in the middle and the numbers on the outsides. All right, take a moment, pause the video, solve this for x using the order of operations you would to solve any equation, then come back and see how you did. So hopefully you've paused the video and have an answer, and now we can see if you were correct. All right, you should have gotten negative 5 and negative 2. Okay, now we start to graph this. Negative 5 is going to have a bracket to the right, and negative 2 is going to have a parentheses to the left. And again, since it's and, they're facing each other, and you're going to just graph in between them. Lastly, your interval notation should be a bracket negative 5, comma negative 2 with parentheses. Okay, so these are examples that you can use with simple compound inequalities. Next, we're going to look at the more complicated version. It looks like this. The reason this is more complicated is now we have more than one x. Okay, and the issue is, if you have more than one x, when you do something to one side, you have to do it to all 3. You'll never get all the x's in one place. You'll always have at least 2 x's in the problem. Okay, so there is a method to solve this that we can use that makes it a lot simpler. And that is, we're going to break the problem into pieces. The first piece is going to be surrounded by the blue. So we have the entire left side and all of the middle. Okay, a common mistake that students will make is they'll take part of the middle, but not the whole thing. They'll take like 2x plus 5 is less than or equal to 4, and they'll leave out the negative 3x. Okay, you have to take the whole piece of all the parts you're taking. So we're taking the left side and the middle and making it one equation or inequality. Now that we have this split up, we can solve this for x. So you're going to add 3x and subtract 5, all right, and then solve for x, which will give you x is less than or equal to negative 1/5. Okay, now that we've gotten the left side done, we're going to do the right side. So that's encompassed with the pink box. Okay, again, we have the entire middle piece, not just part of it. Again, just as I said before, some people just take the negative 3x and leave out the 4. You want the entire middle and the entire right-hand side of your inequality. So again, make that its own inequality equation, and we solve that for x. Okay, we're going to subtract 4 and add 4x. You'll end up with x is less than or equal to negative 3. Okay, so now what we can do is we can graph these. At negative 3, we're going to have, negative 1/5, that's the first one. We're going to have a bracket going to the left, with our arrow going that way. At negative 3, we're going to have another bracket going to the left, going this way. Now, if you remember back a slide or two before, I said these were AND problems. So as an AND problem, this has to abide by all the rules of AND inequalities. And the rule for AND inequalities is we only care about where the two graphs overlap. That happens only starting at negative 3. So this part of the graph we don't care about because it's not where it overlaps. So at negative 3 going to the left is all the graph that we want. Okay, because that's where the two graphs are overlapping. So we write our interval notation to reflect that. It's going to be from negative infinity to negative 3 with a bracket on negative 3. Again, remembering that anything with an infinity is always going to be a parentheses because you cannot include it in your answer because we don't actually know what negative infinity is. Okay, let's look at another example. There we go. So take a moment, try this one on your own, pause the video and see what you come up with. I will have the answers when you come back. So hopefully you've paused the video and have come up with answers, and now it's time to see if you were right. So again, we're going to split up the equations. You're going to have negative 5 is less than or equal to 2x minus 1. That's your first equation, and if you solved it correctly, you should get x is greater than or equal to negative 2. Right? On the other side, you're going to have an equation that is 2x minus 1 is less than x plus 7. When you solve that, you're going to get x is less than 8. So at negative 2, we're going to have a bracket going to the right. At positive 8, we're going to have a parentheses going to the left. And we're going to graph in between them because it is an AND. And finally, your interval notation will be bracket with negative 2, comma 8 with a parentheses. And that is compound inequalities. Please make sure you're doing the practice to get practice at doing these problems, because that's going to be what makes you better. All right, good luck.